post it later today. So it's used for working with very large or very small numbers. When you write scientific notation, in scientific notation, one number is before the decimal place. The rest is after. Okay, so let me give you an example. Suppose you have the number 123,000. Where's the decimal place in 123,000? Anybody? It's like a graveyard in here. You guys alive? You hear me? 123,000 is here. Okay, the decimal place is here. So you want to put it over here according to scientific notation. There's one number before the decimal, the rest are after the decimal. So I'm going to move it over 5 times. I'm going to put the decimal from here to there. So then I can write 1.23 times 10 to the power of what? I jumped 5 times, so it's power of 5. Okay? You take any number, you always put the decimal so there's only one number before it. Let's do another one. So say 456 million. 456 with 6 zeros after it. By the way, anything million is going to have 6 zeros in it. I mean, provided it's a round number. I mean, you could have a bunch of other, it's still called millions. This is called millions because it's got 6 zeros. If it's got 9 zeros, it's called billions. So you should familiarize yourself with that idea. So the decimal place is here, and I want to rewrite this number in scientific notation. I'm going to move it to here, between the 4 and the 5. So it's going to be 4.56 times 10 to the power of, look at all the jumps. 3 jumps, another 3 jumps, that's 6, plus 2 more, 8 jumps. So you're going to say times 10 to the power of 8. You can also go the other way. Let's suppose you have the number 0.00078. And I want to rewrite that as scientific notation. I'll take the decimal and I'll put it between the 7 and the 8, so that we have 7.8 times 10 to the power of something. Let's see how many jumps we have to do to get that decimal between the 7 and the 8. 3, 4. 4 jumps. But now it's going to be to the negative 4. So here's a good rule of thumb you can follow. When the decimal place moves to the left, the power goes up. The exponent goes up. When the decimal moves to the right, the exponent goes down. That's going to help you remember it. So you can try one. Okay, let's look at what it says on page 53. I'll read through it with you. Scientists need to express small measurements such as the mass of the proton at the center of a hydrogen atom, and they show 0 with about 21 zeros, 1673 kilograms, and large measurements such as the temperature at the center of the sun, 15 million Kelvin. To do this conveniently, they express the numerical value of small and large measurements in scientific notation, which has 2 parts. A number, in which only 1 digit is placed to the left of the decimal, and an exponent of 10, by which the number is multiplied. Thus, the temperature of the sun, 15 million kelvins, is written as 1.5 times 10 to the power of 7. If I write 15 million Kelvin, okay, here's 15 million, 15 with 6 zeros after it. Decimal place is here in the original number. If I move it to over here between the 1 and the 5, that's 7 jumps to get there, so you're going to say 10 to the power of 7. See, I moved the decimal to the left, 7 jumps, so the exponent goes up by 7 powers. Look at the examples on, and then negative exponents, same thing except going the other way. So look at page 54, scientific notation, the number 230. Can anyone give me an answer for 230 in scientific notation? $230. The decimal is at the end of the number. What do you say, guys? Anybody? Brittany, what do you say? Where am I going to put that decimal? Between what and what? Any idea? Anybody else? Hey, what's your name? Jessica. Jessica. Here now. And here's your paper. That's what we're covering now. What about Kate? Where am I going to put the decimal to make it scientific notation? Between what two numbers? 2 and 3. Right. So I want to move it from here to there. So 2.3. And how many times did I jump to go from here to there? Twice, 2 jumps. So it's going to be 10 to the power of 2. See? Very easy, guys. There's nothing to it. Let's try another one. 5,601. Rewrite that as scientific notation. Here's your decimal. See who else I can put on the spot here. You guys are too shy. Jessica. What do you think? Where are you going to put that decimal? No? Sorry, maybe it's too early to ask you, Jessica. How about Sandy? Sorry, say again? Between 5 and 6 is correct. So 5.601 times 10 to the power of 1, 2, 3. Okay? All right, try working on the next 2 problems on that sheet. So you got 14 million, 100,000, and 56 million. That's 56 with 6 zeros after it. See what you get. I'll give you a minute to do it, and then we'll answer it together. So I'll, when I finish recording this class, I'll put it up as a link until we can figure out how to work it so that we can record it directly. And by the way, I do have a YouTube website. I have 2,000 videos on YouTube. Okay, I've been posting for about 8 years now. So they're literally over 2,000 videos. There's playlists for every particular subject I teach and other stuff. So you could look at the playlist. There's a playlist for grade 10s, okay? So my name is Massimo Bazzi. So I'm going to be referring you to the videos that I've already recorded. Some of them are 8, 9 years old, but they're specific to stuff we've done. So there'll be links in the grade 10 website for this class that you can watch. There's stuff that I did long ago, and there's more than one Massimo Bazzi in the world. I'm the guy with the blue shirt. There's a picture of me in the little medallion at the top. I'm wearing a blue dirt bike shirt, so you can see very clearly who it is. And then, of course, I'll be the only one with chemistry videos. Okay, let's do this. C. So you have 14,100,000. Decimal is here, and you want to put it between the 1 and the 4. That constitutes 3, 6, 7 jumps. So 1.41 times 10 to the power of 7. Who got that right? Good. D. 56 million is 56 with 6 zeros after it. The decimal place is here in the number. If I want to turn it into scientific notation, I got to put the decimal between the 5 and the 6. So it's going to give me 5.6 times 10 to the power of 3, 6, 7 jumps. So 5.6 times 10 to the power of 7. E. The fraction 2 over 10. Another way of saying it, hi guys.
Morning, sir.
How are you?
Not too bad yourself?
I can't complain. Life is good. So we have a couple of practices. 2, 4, 6, 6 out of 8. Okay, good.
Thank you, sir. Have a good one, eh?
You too. See you guys. I'll give you this. Actually, I'll put it here, that way I don't touch everything, and you can pick up if you don't already have it. That's your schedules. So 2/10. Where do I put my marker? 2/10. Another way of saying 2/10 is 0.2. Okay, so 0.2. And again, in scientific notation, you want one number before the decimal, one after, but it's got to be non-zero, so you're going to put it over here like that. So you're going to get 2.0 times 10 to the minus 1, because you did one jump going to the right, so the exponent goes down. Then F. Is this making sense, guys? Because you're impassive. You're neither making a positive nor negative signs. Are you understanding this? You got to tell me, otherwise I don't know. I'm guessing. F is 0.45013. Okay? And you want to turn it into this, where you have a decimal between the 4 and the 5, so that's 4.5013. That's times 10 to the power of negative 1, because you had one jump going to the right. G is 0.089. You're going to move it to there, between the 8 and the 9. So you're going to get 8.9 times 10 to the power of 1, 2, negative 2. Can you do the rest, the last 3 remaining ones? Use the same technique. Tell me what you got. Put your hand up once you get it. Shouldn't take you more than a minute or so. You guys ever give blood? It's a good thing to do. the last three on that sheet. You have 0.3026. To turn it into scientific notation, you're gonna move the decimal place up between the 2 and the 6. So you get 2.6 times 10 to the 1, 2, 3, 4. 4 jumps. I is 0.30698. You want the decimal place to move up to here, so it's going to be 6.98 times 10 to the power of 367, -7. Anybody get that? Nobody got that? Finally, you have 12 thousandths, 12 over 1,000. The trick for rewriting fractions as a decimal is to pretend you've got the biggest number you can put on there that would not make it 1 yet. So 999 thousandths is the biggest fraction you can have that's not yet 1. So you could say, write 3 zeros, but the last 2 is 12. So what you'd say is, there's 3 numbers in there, so when you write it as a decimal, it's gonna be 0.012. That's a way of rewriting 12 1,000ths. And then from 12 1,000ths, 0.012, you can turn it into a scientific notation by moving the decimal between the 1 and the 2. So it becomes 1.2 times 10 to the power of -2, because you jumped twice to go from where the decimal was to where it has to be to write scientific notation. All right, so that's pretty well it for scientific notation. You can try number 2 for homework. Now let's move on to, try pages 54 and 55. Finish page 54 and do page 55 for homework. On page 55 though, there's a section you might not know how to do unless I show you a couple examples, so I'll do that as well. For those of you who are going to be at home, these are the questions. You can pause it and zoom in. Pause it, take a screenshot, and zoom in if you can't read it. Well, you should be okay, especially if you do it on a computer. Here's the other side of the sheet. Okay. And so guys, this is good for you too, because if you happen to not pay attention for a moment or two, you can watch the video and review what you missed. All right, on page 55 of this sheet, I might create a new playlist. I'll call it Corona Hoax or something, and then you'll have class 1, 2, 3, or I'll put the date, whatever. You'll be able to find out which class was from each day. So even if you miss a class, you can go look it up. Number 1. You got 1.5 times 10 to the 3. Now they give you the scientific notation and they want you to put it back into the regular notation. So what you do is you look at how many exponents there are, so 3. So write 3 extra zeros after the number. So you're gonna say 1.5 with 3 extra zeros, and then you're gonna jump that decimal 3 times over. 1, 2, 3. That's where it's gonna be. So now you can rewrite the number. It's 1,500. Number 2, they give you 1.5 times 10 to the minus 3. So what you do in that case is you write the numbers on the other side. So it's 0. You put 3 or 4 zeros, and then you write your number with the decimal in place, and you jump it 3 times the other way. 1, 2, 3. This is where your new decimal is. So now your new number looks like this, 0.0015. All right, so follow the same procedure with the other ones, and it shouldn't be too hard. The next thing I want to bring up is exponents. We're gonna do the rules of exponents, or the exponent laws, you can call them. There's only 5. Can you see them though? To the edge of the board. Yeah, okay.
Sir, Dorman's G.
This one?
Yeah, yeah.
Okay, don't worry. You made me jump. Okay, laws of exponents. Laws of exponents, there's only 5. They're, it's good to know them and be familiar with them because they actually are quite powerful for doing lots of calculations involving things like volumes and areas, even talking about population. Like one of the most popular myths that's pushed around even by scientists is the overpopulation myth. Even to this day, people think the world is overpopulated. And they talk about the need for reducing the population and, carbon footprint, and everybody's running around like Chicken Little worried about the end of the world. But if you ever took a drive, just about anywhere, you'd be amazed at how much open space there is. In a country like Canada, if you ever try to drive across Canada, I haven't done it myself yet, but I've driven on areas around here. There's just a lot of farmland. There's not a lot of people on the planet. There's only 7 billion of us. If you took every human being on the whole planet and made us stand like an army, it would make a square 87 kilometers aside. Okay, imagine, look at those 9 floor tiles. Suppose that was your space to stand on. If you could stand in the middle of 9 tiles, and then everybody else in the whole planet was made to stand the same distance apart so that everybody had 9 tiles, it's basically 1 square meter, or 1 square yard. The entire population of the Earth would fit on a square 87 by 87 kilometers, and the rest of the world would be empty. So this is so-called overpopulation? No, I'm pretty sure the world is underpopulated. We got lots more room. It's not that we're overpopulated. What we are is under attack by people with political ideas that they want to push on the rest of us, and the rest of us are powerless to do anything about it because we're living our normal lives. But this is precisely where things like Christianity should kick in and inform the mind of a scientist that, hey, you're not allowed to make those kind of decisions for the whole world. Every human being that exists is just as important as every other human being that exists. Nobody has the right to say, no, you're not allowed to make babies, or no, you can't live because whatever, I don't agree with you. That's ridiculous. And in a person who has a good Catholic upbringing, or even a good Christian upbringing, you can see through so-called science, which is really the devil with a mask, if you think about it. But that's part of the reason why we get an education. When you have a proper education, you can identify malarkey when you see it. Okay. Laws of exponents. The first law says that when you multiply 2 numbers raised to a power, obviously it's got to be the same number. You're going to have the same base. Then you add the powers. So x to the power 4 times x to the power 3 is equal to x to the power 4 plus 3, or x to the power 7. When you divide numbers raised to powers, say you have x to the 7 divided by x to the 4, then you subtract the powers, you get x to the 3. Another way of writing the same thing would be to say x to the 7 over x to the 4. That would give you x to the 3, because really a fraction is just a division. You know the division symbol? What does it look like? It's a line with a dot above it and a dot below it. What do you think that symbolizes? It's symbolizing a fraction, right? Third law of exponents says that when you take the reciprocal of a number, say you have x to the power of 3, if you take the reciprocal of it, you change the sign on the power to maintain the same value. All right, so x to the power of 3, if you put it 1 over x, the power on the 3 has to be negative. Another way of saying that, say if you have x to the 4 over x to the 3, you could rewrite it upside down with the 3 on top and the 4 on the bottom, but that you have to reverse the powers. 4 and the 3 become negative to maintain it as equal. Can I erase the j now? Can I erase j? Okay. So the fourth rule is when you raise a power by a power, you multiply the power. So x to the power of 3 raised to the power of 4 gives you x to the power of 12. You can do it even with fractions. You could have x to the 1/2 raised to the power of 1/2 is x to the power of 1/4, because 1/2 times 1/2 is 1/4. So you can even do it with fractional powers. It doesn't have to be whole numbers. And the last rule, which is the easiest one to remember, is that anything to the power of 0 equals 1. And we could do a couple examples of each one of those rules. So let's do some practice. Let's say I have x to the power of 2 times x to the power of 3 times x to the power of 4. What's that going to be equal to? Following rule number 1. What you gonna get? Add up the powers, guys. 9. X to the power of 9. Good. Let's do another one. If you have x to the power of 1/2 times x to the power of 1/2, what is that going to equal to? Just add the 1/2s. What's 1/2 plus 1/2? If you have $50 and you add another $50, how many dollars do you have? Nobody knows? $1. Okay, so you're gonna get x to the power of 1, which is basically just x. You don't have to write the 1 because it's understood if you just write x. And now let's do rule number 2, examples. Suppose you have x to the power of 100 divided by x to the power of 20. Your calculator can't do that, by the way. Calculator cannot enter a number that has a power higher than 99. Your iPhones, I think, go up to 160. If your number is bigger than that, then you get error. You get an error message. So we're dealing with a number here that scientific calculators can't handle. But you know the simple rule, so you can do it. What's 100 minus 20? 80. So it's x to the power of 80. That's your answer. B. Let's do another one like that. 5x to the power of 10 divided by x to the power of 2. What do I get? When you divide, remember that you subtract the powers. And remember, x represents any number, but it's got to be the same number for this to work. So x to the 10 divided by x to the 2 is x to the 8. Let's do an example of number 3, where you can, let's say x squared times x to the 3 over x to the minus 4 times x to the minus 5. Remember, when you do a reciprocal of a number, when you bring it from downstairs to upstairs, in other words, the power changes sign. So you can rewrite this whole thing like this. You can just say x to the 2 times x to the 3 times x to the 4, positive 4 times x to the positive 5, and then you simplify using rule number 1. 2 plus 3 plus 4 plus 5 is 5 plus 4, which is 9, and 9 plus 5 is 14, so your answer is x to the power of 14. See? Super easy. if you know the rules. And then for part B, let's do another example. Let's see if you can do it yourselves. X to the power of 2 over x to the power of negative 3. What's that going to give you? Simplify it. Follow rule number 3 first, and then follow rule number 1 to give you the answer. It'll just be, there's only going to be one x in the final answer. Anybody? All right. You can simplify by saying this: x squared, bring the x to the minus 3 into the numerator from the denominator, and you'll get x to the power of positive 3, because you brought it up. And then x to the 2 times x to the 3 gives you x to the 5. Anybody get that answer, but was too shy to share? Example number 4. You have a power raised to a power. So you can say x squared raised to the power of 3, and then you can even raise that to the power of 4. What would you get? Just multiply the powers. 2 times 3 times 4. 2 times 3 is 6, and 6 times 4 is 24. So you get x to the power of 24. And last of all, 5. If you have x to the 3 over x to the 3, what's anything over itself equal to? What's 2 over 2? Anybody? 2 over 2 is 1. What about 3 over 3? Still 1. How about x cubed over x cubed? Still 1. But you can solve it 2 different ways. You can show that x, first of all, you know that it's 1 because anything over itself is 1. But you could just simply put that x3 upstairs, so it becomes times x to the minus 3, and then when you use rule number 1, when you add these two together, 3 plus minus 3 gives you 0, so x to the 0 is what you get. But the rule says that anything to the power 0 equals 1, so you still get 1 as an answer. So when you solve a problem 2 different ways and you get the same answer, there's a good chance you did it right. But it's still possible you did it wrong in 2 different ways, but chances are lower if you get the same answer doing the 2 different techniques. All right, let's see if we have any practice on this. Not for that. The next thing I'm going to do is the prefixes for the SI system. So just finish copying that. The prefixes for the SI system is what we use to avoid saying large numbers by just having a letter. Say, for example, when you buy your phone, you can buy a phone that has anywhere from 16 gigabytes of memory up to, I think now, 512, right? Maybe even, are there any terabyte memories in the phones yet? Nobody has one with terabyte? Yeah, so phone memories tend to double every so often, and they use that as a selling point because the more memory you have, the less stuff you have to delete, right? You can keep your old videos and memories because you have if you have a big phone memory, you can record a lot of video with 500 gigs of data. I mean, with a memory, you can record about 100 2-hour-long movies. And that's a lot. I mean, they used to say back in the day, I remember in the 80s and 90s, they used to say, oh, one day computers are going to have terabyte memories.
and then you won't have to erase anything anymore. Little did they know about video, high HD videos. Now, you can fill up your phone memory pretty easily, even with a terabyte memory. I think we're gonna have to go to petabyte memories before we can even start talking about not erasing anything. I don't know if we'll ever reach that, because each time you go to a different level, you're 1,000 times more. If you have a kilobyte of memory, then you go to a megabyte is 1,000 times more than a kilobyte. And then from a megabyte to gigabyte, again, 1,000 times more. And then you go from gigabyte to terabyte, again, 1,000 times more. When you get to terabyte, that's a very substantial amount of memory. At some point, I imagine, the phones will have enough memory that they can record every moment, every waking moment of your lives. I'm not sure that's a good thing either. I don't know if you guys have seen any of the Black Mirror TV series. In one episode, people have embedded memory chips so they record with their eyes, and they can go back and access everything they've done, and it ends up ruining a marriage because the husband notices something funny in the way the wife is acting. So he goes back to an evening that they had where they were all having dinner with friends, and he reviews the video, and he sees that his wife was acting kind of strange around one of the people sitting at the table. So then he realizes there's something going on between them. So, you know, right now we have to rely on our own memories, but imagine a world like that. Black Mirror is very good at portraying dystopic scientific futures. Dystopic means a world where things went crooked. In another one of the episodes, they have a system where they give you a rating. Everybody gives everybody else a rating. So if somebody cuts in front of you at the line in the store, you can give them a negative rating, and the rating drops. And if your rating drops below a certain level, you can't even get on an airplane. You can't fly. Or, you know, people won't give you service. And there's this lady who's real keen on being high status, and she always smiles at everyone. She's very fake. But at one point she goes to an airport and her rating has dropped to like 4.3, so she can't get on a certain flight because it's only for people who are above 4.3. So she starts swearing at the countertop and at the lady behind the counter, and then they kick her out of the airport, and her rating drops down to 3, and it's just a nightmare. And believe it or not, that is actually happening in China right now as we speak. They have that system in place. They have a social credit system. If you say jaywalk in China, they have cameras everywhere recording your every move, and your social credit rating drops. And the same system, by the way, they're trying to implement it here. You'll notice when you're driving on the road, it says your speed is, and they tell you 65, whatever. One of these days, they're going to replace those cameras with cameras that write you a ticket automatically if you go over the speed limit. And I don't know about you, but I'm not comfortable with that at all. Who voted that in? I didn't vote for that. Did you vote for that? Did you vote to be surveilled at every waking moment? Did you vote to have an eyeball peering into your bedroom window at every moment? But that's what it's coming to. And by the way, when you have one of those things on you, there are people who can, if they know the codes, they can hack into it. They can turn on a microphone, turn on your camera. They already listen in to everything we say. When I was working with my dad this summer, I was chopping wood, using wood chippers, using a tractor and all sorts of stuff. I got commercials for tractors showing up in my Instagram feed. What does that tell you? The phone is listening. They listen to what you say. And you should be concerned, because privacy is something important. It's not something that anybody should be allowed to take away from you. How would you feel about a police officer sticking his eyeball against your bedroom window every night? Would you be okay with that? I wouldn't. But yet you have one sitting next to your night table every night. Recently, a company called Huawei got in trouble because their Android phones have codes where you can basically backdoor your way into somebody else's phone. So China was using these codes to spy on corporations. So you'd walk into a high-tech company with your Huawei phone, and somebody in China could turn on your microphone and listen to what you were saying. So they were stealing corporate secrets. They got in trouble for it. The US figured it out, and the CEO of that company came to Canada, and the US said, please arrest that CEO, what they're doing is illegal. So Canada arrested the CEO of Huawei on behalf of the US, because the US has an extradition treaty with Canada, and the Chinese government was so upset that they arrested the Canadian ambassadors. So that's a very sketchy incident. You realize how bad that is? You have a country arresting the ambassadors. Maybe I'm getting wrong about the ambassadors. Anyway, they arrested some Canadians in China, which was it's an international incident. It's an act of war, just about. But isn't espionage also an act of war? Isn't it wrong to spy on people? How would you feel if you found out somebody you knew stuck a microphone on you so they could hear what you were saying when you thought you were alone or with friends? Would you be okay with that? You shouldn't be. And you should look into it, because it's a matter of very urgent importance, because our privacy is going down the drain in every way. And we shouldn't get used to it. It's wrong. It's wrong for people to invade your privacy. Your privacy is a God-given right. Somebody asks you questions they have no right to know anything about, you can say, I'm not divulging that information, it's none of your business. You have no right to know. You know, when people say to me, oh, would you like to conduct a survey? I say, no, thank you. I don't feel like telling you my opinion on the matter. Now, as a teacher, you're gonna get more than my opinion. You're gonna get what's going on in the world and my opinion. And I think it's important for you to know. You don't have to agree with my opinion, but I think it's important for you to know what's going on. All right, let's do the next thing. I think one of the great errors of our age, which sort of snuck in in the back door, is the establishment of what's called a technocracy. In a technocracy, you have computers doing the dirty work. This morning I tried to post a controversial scientific point of view. Facebook didn't let me. I wrote a sentence, I copied the link and I tried to post it on Facebook, and Facebook just erased it. It didn't go up. So that kind of stuff should scare people. It should scare people a lot, because that means somebody's controlling what we're allowed to believe.
Sir?
Yeah,
Can I have the napkin?
absolutely. See, in ancient Rome, one of the things that the senators and the emperors did to keep people quiet is they gave them lots of games. So they'd have these gladiatorial fights. They would have wild animals being sacrificed by gladiators. They would arrest Christians and throw them in the arena and let lions eat them and do all sorts of horrible things. And people were entertained, so they never stopped to think, what are these horrible politicians doing? We have the same thing in our society now. They don't use gladiatorial fighting, but they do use movies, they use sports, and they use all kinds of distractions. And they flood us with distractions, so people never realize what's going on behind the scenes, stuff that should really be worrying them, because their future is going to be affected by it. How would you feel if one day in the future they say, okay, it's quarantine tonight, Friday night, nobody goes out? Would you obey? And yet you're obeying right now. The pandemic's been over for months. There's nobody in the hospitals, and yet we're all sitting here wearing masks. Safety, 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 sanitize. People are getting staph infections on their face from wearing masks all day. And we're running around like Chicken Little, worried that the sky's gonna fall on us. Have you heard of anybody actually getting sick in the past 2-3 months? I haven't. I know people that work in hospitals, the hospitals are empty. They keep on saying 300 people tested positive. Really? I remember 6 months ago, we were talking about people dying in hospitals. Now we're talking about people testing positive. What happened in the intervening 6 months? That's not good science. If you're going to start talking about people dying, you got to continue talking about people dying, not sort of transition into people testing positive. Oh, on top of that, they say asymptomatic. So we're all suffering from a disease that has no symptoms. How interesting and hilarious and pathetic. On top of that, there are drugs that treat the disease very effectively, and they're prevented from being disseminated. People say, oh, it's a conspiracy theory. Hydroxychloroquine causes people to have heart problems. Meanwhile, the drug's been on the market for decades, and it has no such problem with everybody else who's been taking it. Okay, when you want to say big numbers, like say, if you want to say 1,000, you could put kilo in front of a number. So for example, a gram, you know what a gram is, it's about the weight of a paperclip. But a kilogram is 1,000 grams, so it's the weight of, say this bottle is about a kilogram. So yeah, 1 liter of liquid is about a kilogram. So I'll start from the very biggest and go down to the very smallest. The very biggest is called Yata. And use a capital Y for its symbol. And it means 10 to the power of 24 in front of whatever you put it. I've never used Yata. Or even the next one. But at least once in your life, you'll hear about it. 10 to the 21 is zeta. I've heard of exa. Exa has a capital E, it means 10 to the power of 18. Peta is capital P, and it means 10 to the power of 15, or quadrillion times. Tera, capital T, it means 10 to the 12 or a trillion times. So if you had a trillion bulls running in the street, you could say it was a terrible. There is an audience. Yes, there is. Giga. Takes some getting used to. 10 to the 9. Giga is 10 to the 9. Mega is M, 10 to the 6. Kilo. Now, here's where there's a dividing line. I don't know why they put it here, but they use lowercase with everything below mega. So when the multiplier is 1,000 times, then you start using lowercase letters. So kilo is 10 to the power of 3. Then they stop jumping by 3s. You see how it goes 24, 21, it's jumping by 3s. But when it gets to 3, they start jumping by 1s. So the next increment down is hecto. It's a lowercase h. That means 10 to the power of 2. So hectogram means 100 grams. Kilogram means 1,000 grams. And you can get decagram, which means 10 grams, and it's a DA for the, it's the only one with 2 letters, DA. And deca means 10 to the power 1. It's like, it's a 10 times 10 multiplier. Now we're gonna go the other way, we'll make things smaller. Deci uses a lowercase d, and it means 10 to the minus 1, it's 1/10. Centi is 1/100th. Lowercase c, 10 to the minus 2, it equals 1/100th. So you heard of centimeters. There's 100 centimeters in a meter. Milli is 1/1000th.
Micro is a U with a little tail on it. Looks like a U wearing a tuxedo. It's got a little stem on the end. That means 1/1,000,000th. Now we're going back, jumping by threes, right? So it goes from -3 to -6. That means 1/1,000,000th. So a micrometer is a millionth of a meter. A microgram is a millionth of a gram. And you go even smaller than that, it's called nano. If you have a billionth of a nano, you have a nano. Pico means 10 to the -12. It's a lowercase p, 10 to the -12. I'm not gonna write 1 trillionth, you get the picture. Just keep on adding 3 zeros. Then you get, oh, sorry, it's not with a K, it's with a C. Pico, by the way, the word pico is used in Italian. Piccolissimo means very small. There's also a musical instrument called a piccolo. It looks like a small flute. Femto is 1,000 times smaller than pico, and it's symbolized with a lowercase f, and it's a multiplier of 10 to the -15. Then you get atto, zepto, and yocto. If you take the first letter of each one, it spells phasey, and it goes down by 3 each time. 10 to the -18, 10 to the -21, 10 to the -24. Okay, so those are all the multipliers that you would use in the metric system. I would say you should know up to femto for sure, okay? Up to there, and you should definitely know up to peta. Okay, so the ones from these ones and these ones. These extreme ones don't get used all that often. I've actually never seen them in use. They're just not that commonly used. It's good to know them as, like a curiosity. Eventually also, I would like to teach you how to make a conversion factor. So I've appended some videos for you to watch on the grade 10 profile. Watch those videos, okay? It's a repetition of a lot of the stuff I said here. If you didn't get it the first time, you'll get it by watching the videos. And then I'm gonna put this video up as well. And I'll invent some clever name for it too, so that you go to the playlist and you can review any class we've done this year. I'll just record all of them. Whether I can do it with Google or YouTube or whatever, I'll find a way. It doesn't look like Google's cooperating very well. So it might end up being that I put it on YouTube, but then append it to Google, because the school wants us to do everything through Google. So it will be on Google, just that for the time being, I have to record it on YouTube. Now, how do we convert between units? I apologize, by the way, that this class is brutally long, because it's 2 hours. It's only 10:30 now, we have an hour to go. But we could take a little suitable breaks, break up the boredom. You finished copying? Does anybody know the definition of the word jaded? Somebody look it up on their phone.
Read me back the definition of a word. It's spelled J-A-D-E-D. Jaded. Did you look it up? What does it mean? Tired or bored. Even more significantly, it is what happens when your mind has been overstimulated by too many flashy things. You know what? I've been teaching 25 years, and it's a trend, it's somewhat of a trend I've noticed in students, is no matter what you say, students don't seem to care one way or the other. A lot of people are burned out on social media because they're constantly watching stuff that stimulates their brain, so everything else is boring. It's a trend you gotta watch out for. Because if you're spending all your time watching memes and you know, people doing crazy things, life becomes kind of monotonous and boring. And let's face it, it is a lot of the time. But what's bad is if you succumb to it and you just sort of look at life with, there are lots of exciting things in life, but you have to refine your spirit to tune into them. Okay. The next thing I'm going to do is called conversion factors. Whenever you want to, when units of one kind are substituted for another, it is necessary to equate their values. Obviously, you know, if I tell you my height in inches, I'm going to say 69 inches. But what's my height in centimeters? Well, it turns out it's 175. Is there a number that you can take inches and turn it into centimeters? The answer is yes. That number is 2.54. So whatever inch measurement you have of something, if you multiply it by 2.54, you'll find out centimeters. So if you take 69 and multiply it by 2.54, you get 175. So whenever you use a unit, whenever you make a measurement of something, you have to tell what units you're using, or else it's going to be meaningless to people. You say to me, oh, how far is it from here to my house? And I say 5. What's wrong with that? What's wrong with me saying, I'm 5 from here? 5 what? It's got to be, you got to give some units to your measurement. So you can say 5 miles, 5 kilometers, 5 minutes of travel. You know, you've got to specify what units you're using, or else your measurement is not going to help anyone. So scientifically speaking, because units and measurement are so important, we have a system whereby you can convert one type of measurement into a different type of measurement. And let's show you some example. The CN Tower. Is 450 meters high. How many inches is that? You need some conversion factors to do that. There's 2 conversion factors you need to use to solve that. First of all, you need to know that 1 meter is equal to 100 centimeters. And you also need to know that 1 inch equals 2.54 centimeters. So if you know those 2 conversion factors, you can
you can use them to change your number of meters into inches. This is how you do it. You get 450 meters, and you're gonna write a multiplication. And you're gonna take your conversion factors that has meters in it and turn that measurement into centimeters. But you can write it two different ways. You can either write 1 meter per 100 centimeters, or you can write 100 centimeters per 1 meter. One of them you can use, the other one, if you use it, will give you the wrong answer. How do you decide? Well, the way you decide is you wanna cross out meters. So you have to write the fraction that's going to allow you to cross out meters. Which one of the two is gonna allow you to cross out meters when you write it next to 450 meters? You don't know. So I will tell you. It's 100 centimeters per 1 meter. That allows you to cancel meters. So you're gonna get 450 times 100. It's gonna equal to, add 2 more zeros to 450, and you get 45,000 centimeters in height. But we're still not finished. The CN Tower is 45,000 centimeters tall, but you want to convert it to inches. So we have one more conversion factor here, which we can write as 1 inch per 2.54 centimeters, or you could say 2.54 centimeters per 1 inch. Which one are you gonna use? Well, the one that allows you to cancel centimeters, so the one that has centimeters in the denominator. So you're gonna use this one. So times 1 inch per 2.54 centimeters. Centimeters will cancel, and let's do the math. I can't do that in my head, so I'm gonna use my calculator, which is not here. Give me 1 second. So 45,000 divided at 2.54 gives you 17,716.5354. Obviously, you're not gonna write that many. You only got 3 numbers in the original, so you're gonna say 17,700 inches is the height of the CN Tower. Okay? I had a worksheet for this somewhere in here. There it is, okay. This is fairly easy. I'll give you five questions, and I'll give you the conversion factors that you need to solve them. Let's put it so that this board is more visible. That way you can. Okay. So here's the instructions for your homework. Convert the following measurements to kilometers. some of the conversions you're gonna need. First of all, 1 mile equals 5,280 feet. 1 foot equals 12 inches. 1 inch equals 2.54 centimeters. I'll write the whole word, centimeters. What else? 1 meter equals 10 decimeters. 1 meter also equals 1,000 millimeters. One yard equals 3 feet. I think that covers it. That's all the conversion factors you need. You don't need to use every single conversion factor for every problem, but at most you might use 2 or 3 of them, okay? I'll just do one of them with you to show you how that works, and then you can work on it on your own. So I want to convert this into kilometers. Oh, I forgot also that 1 kilometer equals 1,000 meters. Okay, so let's do the first one together. You have 23.896 centimeters times 1 meter per 100 centimeters. Why did I write it this way? Because I want to cancel centimeters. Then I'm trying to turn it into kilometers, right? So I got one more step. There's 1,000, is 1 kilometer per 1,000 meters. So that allows me to cancel meters. So your final answer is 23.896 divided by 100 divided by 1,000. You know what? I'm going to do this one without using my calculator. I'll just do it using exponents. So I can rewrite this number, 23.896 times 1 over 10 to the power of 2, because that's what 100 is. And okay, I've already eliminated centimeters. And I could rewrite 1 over 1,000 as 1 over 10 to the power of 3. But remember the rules of exponents? If there's a 10 to the power of 2 in the denominator, when I bring it to the numerator, it becomes 10 to the negative 2. So my answer can become 23.896 times 10 to the negative 2 times 10 to the negative 3. I've gotten rid of those fractions. Multiply all that together and you get 23.896 times 10 to the negative 5. Is this in scientific notation? No, because I have to move the decimal to the left by 1 unit, and if I move it to the left 1 time, my exponent goes up by 1. So it turns into 2.3896 times 10 to the power of negative 4 kilometers. Exponent goes up, meaning it becomes more positive. Okay, so I didn't use a calculator to solve that, and yes, it is correctly done. One more example. I'm pretty sure this is, I have this somewhere online, so if you look through my profile, you will find it, because I've done this sheet over the years many times. Let's do number 2 together. So number 2, it asks 562 inches. I wrote it funny. Didn't put enough space. 562 inches. Okay, so start off with 562. I want to turn inches into something that is getting closer to kilometers, so let's turn it into centimeters. So I'm gonna say 2.54 centimeters per 1 inch. I won't worry about the number just yet, so I'm getting rid of inches. And now I wanna turn it into meters. I know there's 1 meter per 100 centimeters. That allows me to cross out centimeters. Again, don't worry about the numbers yet. And then I make the step to kilometers, and the conversion factor from meters to kilometers is 1,000, so 1 kilometer per 1,000 meters. And now I can calculate it. So when you use your calculator to do this, numbers that are in the numerator are multiplied together, and numbers that are in the denominator you divide. So what you would enter in your calculator would be 562. And also, when you have a 1, don't bother doing it. What's the effect of 1? If I multiply something by 1, what do I get? The same number. So you don't bother doing it in your calculator, you get the same number. So all the 1s you can just ignore. But if there's a number in the numerator, you multiply it. If there's a number in the denominator, you divide it in your calculator. So when you do this in your calculator, you're gonna say 562 times 2.54 divided 100 divided 1,000. You do it all at once, and you get the correct answer. It'll be 1.47 times 10 to the minus 2. So the correct answer here is 1.47, no, 1.42748 times 10 to the minus 2. There's your answer, okay? There's your conversion factor. I'm gonna show you the answers on the video. So if you get stuck at home, pause the video at the right time. The timestamp is gonna be 1 minute, 13 seconds. An hour, 13 minutes, and 0 seconds till about 20 seconds. So I'm holding it there for a while so you can see it. Okay, so your answers are at 1 hour, 13 minutes. Why don't you try doing that now? You have about 15 minutes left in class. You can use it how you wish. I'm going to stop the video now because we're already at over an hour of recording.